let's see if we can trick it. I'm gonna drop my real column store index. Now, I had a real column store index before that had real data in it with all of those columns. I'm gonna use a hack now, and we're getting into undocumented territory that is not technically supported. So if I get my hack working, it's possible that maybe I apply a cumulative update and my hack stops working, right? Because this is not supported, this is not documented, this is not necessarily reliable. But the idea is I'm gonna create an empty filtered, non-clustered column store index. I have the same non-clustered column store index definition right here, but I've added a where clause that simply cannot be, right? First name ID cannot be equal to -1 at the same time it's equal to -2. It just can't. So no rows can go into this non-clustered column store index. This is a hack that Itzhak wrote about as well. And the idea behind this hack is I want batch mode, and I want those cool new operators. But maybe the table isn't otherwise suitable for maintaining a column store index. So if I create an empty column store index, maybe I can trick the optimizer. Like I said, not supported. Behavior could change at any time. Your mileage may vary. But will it do what we want? So now I'm going to look at an estimated plan. Okay, I have that empty column store index. What do I get? I don't have the Rowstore index. Remember, I just have the clustered index. Well, it says, let's go ahead and run this. It says I'm going to do the clustered index scan. And I've got to do the sort, but I can still do the new window aggregate operator. So what we're comparing is clustered index scan and sort plus window aggregate operator 2. We did it with a real column store index last time. So if I run this for real, hey, that was actually faster. That was only 4 seconds. Using the Rowstore index with the magic new operator, even though we had to have the sort, if we look at our sort here, this is a batch mode operator, so the actual time stats are only for this operator. The sort took 2 seconds. Okay, the sort is taking a big chunk of our time. The window aggregate operator, it took 58 milliseconds. How is that possible? It's seriously like, how is it so fast? It's magic. It's magic. It's also batch mode, of course. And then we have more things to do, but like we've just saved so much time on the whole windowing part that like, woo. Well, all right, let's try to get rid of that sort. I'm going to recreate my Rowstore index that pre-sorts the data by my partitioning columns, as well as my order by column, and then also covers as well. In the past, it wouldn't use this for threshold equals 500. And if I did Control L to look at my estimated plan, once again, I'm back to this slow window spool operator. I'm not, this is our row mode window spool operator. And I do have, like some of these operators farther up in the plan going to batch, but not the ones where it's actually slow. Well, what if, is this a given with my query, or is it just something about my query? I've been using threshold equals 500 so far. What if I say threshold equals 1,000? I did an estimated plan again, and sure enough, if I change my threshold, it decides, oh, I can use this Rowstore index, and now that my estimated rows I'm going to deal with have changed somewhat, okay, I'll give you your window aggregate batch operator. So it's not that it can't do it. There's just something about the way my query was optimizing with the costs and the row estimates where it didn't think it was worth it. Well, I think it's worth it, right? Let's go ahead and run this for threshold equals 1,000. And I got my results back in 3 seconds. Now, my results are different because I changed my threshold. We can see that in Alabama, the name Skylar passed the threshold in 2015. There were at that point a total of 1,004 Skylars, whereas the previous year there had only been 854, right? Maybe, and Harper also the same year. I always think this is interesting. Jalen. Names that I don't know, but I like. Well, where exactly is the estimate tipping over? 689 and 690 is where it changes. If I do an estimated plan at 689, I have row mode window spools. If I do an estimated plan at 690, I have window aggregate operators. Well, I always want that window aggregate operator. So what I'm going to do is I'm going to add a hint. And in this case, there's a bunch of different hints I can try. I'm going to say, in this case, I want you to use the legacy cardinality estimator for this query. By default, this is using what's called the new cardinality estimator in SQL Server that got added in 2014. I believe we got new cardinality estimator. I'm like, I believe it was 2014. Someone correct me if I'm wrong. My memory of dates is not that great. But I'm saying go ahead and use the old one. Use the one that's SQL 2012 and higher. And I don't want to change my compat level for the database. Changing my compat level changes a lot. I don't want to change my legacy cardinality estimation for the whole database either. I just want to tweak it for this query. I don't want to impact anybody but me. I could use other hints. In fact, the max_top_1 hint gets the window aggregate operator in this place, but I still want parallelism to be possible for this. So I've chosen to use legacy cardinality estimation. There are other hints you can use, right? You could test out and play around and see in terms of the other ones what they do for you. That's always kind of fun. But now I'm going to say, and I could have used an optimized for hint. There's lots of different hints I could have used. But now I'm going to rerun with threshold 500, and I'm going to look at my plan. It did decide to go single threaded. I didn't force it. It decided to do it, but I have my batch mode window aggregate operator. I have my Rowstore index. Decided to use my Rowstore index, give me the new batch mode window aggregate operator. There is no sort in here, right? Data is pre-sorted in this Rowstore index. And looking at my timing here, 297 milliseconds for this operator. That's for the operator, which is batch mode. Well, how long did it take to get the data out? Actually, pulling the data out of the Rowstore index took 2.6 seconds and is single threaded. So we could play around more to see if we could get it all to go parallel, but we are much faster than we were at the beginning. I can even run this for threshold equals 1. And with that optimization hint in there, and this is going to return all of the rows, names only get reported in here if they have 5 names or more. So I'm saying threshold equals 1, right? This one, I am still, even when with that hint in there, even when I say threshold equals 1, I still get the fancy new operators. And we're still finishing in 6 seconds, even though we're displaying 309,000 rows, much faster than the 30 seconds we started out with. That new operator is pretty awesome there. So we're going to clean it up. And at the bottom of your script, if you're wondering about why do you have 2 CTEs in there, could you combine them type thing, at the bottom of the script, I walk you through why there's 2 CTEs and they're just playing around with the window functions. So if that was one of your questions where you're like, how come? Because someone usually asks that question when I have 2 CTEs like that, then the answer's in there.